Okay, so let's have a look how we find the coordinate of the turning stationary point. So this is the cubic equation. So it's going to go like maybe like this. So when the equations let me just plot a graph for this equation. Okay, the graph of this equation will look something like that. So this is a graph I got from the graphing calculator Desmos. I entered the equation and it just gave me that one. Now we need to find the coordinate of the stationary point. So stationary point is the point where the gradient is 0. One stationary point is here and one stationary point is here. We need to find out this one and then we can check by plotting the graph up to the software. So how do we have a look? The first thing we do is we differentiate this thing, differentiate the equation. When you differentiate the equation, you will get dy over gradient, which is dy over dx, and that will be equal to 3x squared plus 6x plus 0. So that's it. So I got that bit. Now, you need to remember one thing. At the turning point, at the point where the graph actually turns, at the turning point or at stationary point, or sometimes we refer it as turning point, the gradient is 0. dy over dx is 0. So gradient has to be 0, which means 3x squared plus a 6x should be equal 0. Now you need to actually factorize that one, get an answer. So if 3x plus 6x, 3x squared plus a 6x is 0, I can take 3x common and I'm left with x plus 2 equals 0, which means either the 3x equals 0 or x plus 2 equals 0. And if I move the 2 on the other side, x becomes a minus 2. So I got one coordinate. And that one, I divide both sides by 3. X is 0 over 3, which is just a 0. So I got two coordinates for x. I need to find the y. To find the y, I need to actually put this one back into this equation. So the y will be, I put that one, instead of x, I put 0. So 0 cubed plus 3 times 0 squared plus 3. That will give me y equal 3. So I got y equals 3. So one of the coordinate is going to be 0, 3. X is 0, y is 3, which is that coordinate. So this is one turning point, 0, 3. Just call that one turning point. Now, the second turning point is when x is minus 2. So let's have a look at that one. So I need to find the x is minus 2. I need to find the y. So then y equals to minus 2 cubed plus 3 times minus 2 squared plus 3. So that is going to be minus 8 plus 12 plus 3. So that's going to give me 15 minus 8. So that's around y is 7. So this coordinate is going to give me minus 2, 7. So this one is minus 2 and 7. So now I got two points, two stationary points. That point is 2, 7. That point is 0, 3. Just pause the video if you got any questions. Okay. Now, if we want to find the coordinates of the stationary point, we differentiate once. We find the dy over dx. When we got the dy over dx, put that equal to 0, find the value of the x, and find the stationary point. Now, if the question is find the nature of the stationary point, nature of the stationary point means is that a maxima? Maxima is like here where it curve has to come down, or it's a minima. Minima is that value where it has to go all the way up after that one. The minimum value it can achieve, and after it cannot go further lower than that one. So how we find the nature of the stationary point? We already got the stationary point, but let's say, I wrote few things. So let's say first we differentiate. We already differentiated that one. and we got the answer as 3x squared plus 6x. Okay. This is the first differential. Now we differentiate again. When you differentiate again, that becomes a dy squared over dx, and this becomes 6x plus 6. Okay. This is my second differential. Second differential tells you about the nature of the turning point. Now, when I got this one, how I can relate? I got two values. So when x is -2, so I need to put when x is -2, I need to find out what is d squared y. So d squared y over dx squared when x is -2. So I would put -2 here. 6 times -2 plus 6. We don't care about the value. We just care about it's a positive or a negative. This will give me how much? -6. We don't care about the 6. We just care about the minus. So it's negative. It's negative. If the second differential is negative, then it's a maxima. Maxima is mean it's a top point. After that one, it has to come down. Now I need to do that point, which is 0, 3. So now when x is 0. So I need to put that one back into the equation. D squared y over dx squared is going to be 6 times 0 plus 6. So that's now this time it's a 6, positive 6. Which means when, so this is a positive, which means if the second differential is positive, then it's a minima. Second differential is positive, so that's a minimum. So it means like it has to go, and after that one, it can only go up. And based on that information, I can actually plot the graph without looking at that graph. Yep.